Hi class, let's take a look at problem G. Now, I do need you to take note on problem G because it looks very similar to what we did on the previous problem when we multiplied conjugates, but in this situation, this one has a total of two terms that are being multiplied. So technically you have this quantity multiplied twice, which actually represents the quantity of x minus 2 times the values of x minus 2. And that's what we end up foiling. So the x is going to multiply these two, the negative to those two. And let me start with the x. So in this case, this will be an x to the second minus a 2x and minus another 2x plus a 4. Now in this case, these are not conjugates. Notice that the middle terms actually combine. So this is just x to the second minus 4x plus 4. And this is just another way to express a multiplication of a quantity squared. So this is like a one of the previous ones where you had two terms, but in this case, because the two terms are identical, we just rewrite them as one term to the second, which implies you're multiplying x minus 2 times x minus 2. That's actually it for G. Let's move on to the next problem. And in the next problem, they could have expressed this one as well as x plus 1 to the second. So let me just rewrite it as x plus 1 and x plus 1. And then let's actually distribute the x's. So in this case, x and x is going to be an x squared plus an x plus another x. So multiplying x and x squared, x times 1 is x, 1 times x is x, and 1 times 1 is 1. So plus a 1. Or x squared plus a 2x plus 1. And that's it for this one. Let's move on to the next one. And on the next problem, the multiplication is going to get a little bit larger because you're multiplying a binomial times a trinomial. And these could get very large. So what I'm going to do first is I'm going to distribute the x times these three. And then we'll go back and multiply the 5. So in this situation, this is going to be an x to the third. X and 8x, it'll be plus an 8x squared. X and 3, it'll be plus a 3x. And then we're going to multiply the 5 times those three values. So as we multiply the 5 and the x squared, this will be plus a 5x squared, 5 and 8x, plus a 40x, and 5 times 3 would be a plus 15. And then in this case, we have to look for like terms. There's no like terms on the x to the thirds. So we're just going to end up with a single x to the thirds. Now, let me start looking for x squares. I see an x squared here, another x squared there. So that's going to give us a total of 13x squares. So plus 13x squares. Then we're looking for x's by themselves. 3x and then 40x. And that's all the x's I see. So 43x. And then we're just left with the plus 15. Okay, so let me take a look to make sure that nothing was omitted. And we're good on this one. Once again, the moment that we introduce another term and you no longer have two binomials, these could get really large. For instance, let's take a look at the last problem of this section. And in this case, we technically have the multiplication of two trinomials. So this is equivalent to x squared plus 2x plus 1 times an x squared plus a 2x plus a 1. And what we're going to do here is first multiply the x times each of the terms. So let me just start on the corner here. X and x squared is going to be an x to the fourth. X and 2x, it'll be a plus 2x to the third. X squared and 1 would be plus an x squared. And let me double check. X to the fourth, 2x to the third, and x squared. Next, we're going to multiply. So this is the resulting of the first multiplication. Then let's multiply the 2x times those three. So 2x times x squared, that would be a plus 2x to the third. 2x plus times 2x, it'll be plus 4x to the second. 2x times 1 would be plus a 2x. So that's the resulting multiplication of the 2x. And let me check. So 2x to the third, 2x to the 4x to the second, and 2x. And then on the last one, we're going to multiply the 1 times technically every one of the terms. This is the easy multiplication, since we're just going to get plus an x squared plus a 2x plus a 1. And that would be that resulting polynomial. Now, our next step, it's crucial because we technically have a large expansion and we now have to try to combine them all into a single polynomial, preferably write it in descending order. So let me start with the highest exponent, and that would be an x to the fourth. I only see a single x to the fourth. Next, we're going to start combining the x to the third powers. So I see 2x to the third here, another 2 there, and that's it. So that's going to give us plus 4 x to the third power. And let's take a look at x to the seconds. So here's an x to the second, here's another x to the second, and another x to the second. So 4, 5, and 6. So plus 6 x to the seconds. And let's look for x's. So in this case, I see a 2x here, another 2x there, which is going to give us a 4 plus a 4x and then plus a 1. Let me box this in and then check all the additions. Okay, x to the fourth, that would be 2, 4, 4, 5, and 6 x squares. 2 and 2 would be 4. Okay, I don't see any mistakes. That's going to be our final answer. And as you can see on the last two problems, any multiplication that involves larger than binomials gets really messy, especially as you combine these. Messing up a single term is going to change the answers for all of these. That's actually it for these set of problems. We'll put the applications on a different video.